So the next thing we need to do is write a algorithm which is going to perform our sort of time step increment. So given current values for the volumes and the ability to get the derivatives using this function, it's going to give me the next like the volumes in after one step in time. So let's call that def step, let's call it step model. So I'm going to take current var values. It's going to take an argument of the current values. So let's call those so it's a list of current values. VA current, VB current, VC current, VD current. Let's just delete the R. Oh no, yeah. Then it's going to return values of variables after one step using forward Euler method. So not a great method to use, but it's simple to code, and as this is just a demonstration, that's what we'll stick to. So it's going to return another list. It's going to be VA next, so that's the next value after the current value we're at. Okay, so how do we do this? So we could just make a note. Method is that a next or x next equals x current plus dx by dt times step size. So calculate its rate of change at the instant we're at, or the current instant, then multiply that by the step size to predict the change in x, and add that to find the next one. So this is the forward Euler method we used last time. So we can just write out this code now. First of all, let's unpack this. So we can copy our code here. This has got a bit muddled. Makes more sense to just note that there. But this time I'm going to use this shorthand to unpack them. So a bit of copy and pasting. Right. So now, to use this method, what I'm going to need to do is find the derivative. So get derivatives. And I need to pass it a list of the current values. So I could just actually call this instead, rather than passing these again. Get derivatives, and I need to put those into something. So let me say So this is shorthand for unpacking. So this is the rate, the current rate at the start of that step. Then we can go copy what we've called it, and I see a typo there. So this is what I'm going to be calculating, the volume of all the next steps, and that's just equal to current value plus the rate of change of each variable times the step size. So if I go down, I can copy and paste, change these, and I need to define my step size somewhere. So let's do that at the top. Let's just call it here. Step size equals 0.1. Okay, maybe not the most sensible place to have it in my code, but let's leave it there for now. I can think about where it might belong later. So then I need to just return it. I found the next value for all my variables to return. I'm going to return this list. Okay, so my two parts of my ODE solver, get derivatives and then step model. So this performs my forward Euler method to get the step size, the values after one step. If I was doing this in a real simulation, I'd need a more sophisticated method.